I will turn things over to Meredith Stinson, Director of Communications with the Ray.
Good afternoon, guys. Thank you for giving us the chance to share our story of the Ray and the projects that we have with solar on the right-of-ways. I am Meredith Stinson, and I'm the Director of Communications for the Ray. The Ray is an Atlanta-based nonprofit. It was started in honor of a man named Ray Anderson. Ray was the founder and CEO of Interface, which is the world's leader in designing and manufacturing carpet tiles. Ray risked his entire family's savings to start Interface in 1970, and it grew to be $1 billion global business in the mid-90s. While at the height of his company's success, Ray was challenged with a question that changed the course of his life. And that was, what is your company doing for the environment? That question began Ray's entire journey for sustainability, and to prove that sustainability is not only good for the environment, but it's good for business. He went on to become the first green CEO, and he began breaking down barriers for clean energy in the business industry. After his early passing, one of his daughters, Harriet, secured a memorial highway, an 18-mile memorial highway. But Harriet quickly realized the issue with putting the greenest CEO's name and a leader in pioneering sustainability on a dirty carbon driving highway. So to right that wrong, Harriet founded the Ray. She founded the Ray in 2015, and in our first 5 years, we have quickly grown to be a proving ground for sustainable technology on the roadways. We've worked with government and public sector companies to build forward future-oriented projects that start with pioneering the first solar roadway in the U.S., the world's first drive-through tire safety station, the second connected vehicle ecosystem in the world, and it's just we've continued our mission to create a zero waste, zero carbon, and most importantly, zero death highways and roadways to build safer infrastructure for everyone. So my colleague, Laura Rogers, Director of Strategic Partnerships at the Ray, who's responsible for transferring and scaling sustainable technology demonstrated on the Ray. Laura is going to tell us a little bit about our projects with solar on the right-of-ways. She's worked for 14 years in federal and state private sectors in the areas of environmental program management, sustainability, energy, and regulatory compliance. Most recently, Laura led the energy sustainability and environmental stewardship policy and programs at the Maryland DOT headquarters. And Laura conceptualized, designed, and executed the Maryland DOT statewide solar program. She has a great background in solar, and she has done a great job with the Ray's projects in solar, and she's going to tell us a little bit about our newest solar mapping tool.
Thank you so much, Meredith. Okay, great. So let's just start with a little bit of background, right? So let's start with the grid. So our current electricity grid does not have the capability to provide enough energy or enough clean energy that we need to electrify transportation and to decarbonize transportation. So what we do know is that we are expecting about 18.7 million passenger EVs to be on US roads by 2030. And this is only passenger EVs. We also know that medium and heavy duty freight is also being electrified and will need unprecedented power. Our grid is not national. So in fact, we have 3 grids. We have the East, the West, and Texas. And there is not much interconnection between those 3 grids. It's underpowered. So, a single mega charger for a Class 8 truck, the big trucks, which is about a 1.6 megawatt charger, will draw the same amount of power as 1,200 homes. So think about that. In an electrified future, a truck stop in a rural area will be asked to deliver about 10 to 30,000 homes worth of power. And so that grid that is built in the rural areas, they maybe have been built for, servicing only a handful of homes or businesses. Next, the capacity is lacking on the grid. So, for example, 40% or 245 new renewable energy projects, which could have powered 7.6 million homes, were canceled within the MISO regional grid. The MISO stands for Mid-Continent Independent System Operator. And those projects were canceled between January 2016 and July 2020. So what we have is a grid that's underpowered and underprepared for electrification of transportation. We literally cannot onboard more renewable energy generation without overpowering the limited remaining capacity. So what should we do about this? We know transportation is the largest contributor to greenhouse gas emissions in the US, just surpassed the energy sector very recently. We're also coming to a time where the energy sector and the transportation sector are looking to, provide fuel for vehicles. So we're on the edge of the future as we speak. So what we can do is we can use our highways to help unlock clean mobility. So what we discovered through working with UT Austin is that by only using the publicly owned land along interstate exits, we could generate up to 36 terawatt hours annually. And that doesn't even include, other types of roadside right-of-way. So imagine how much more we could generate just using our roadsides and building solar along those highways. So this 36 terawatt hours, that's enough to power 12 million passenger EVs. So that's about a third of the amount of EVs that we're expecting on the roads by 2030. And this energy represents an opportunity of about $4 billion annually for state DOTs. So once we build solar, how can we use that solar? So right now, the solar that is built in the right-of-way has been connected to the grid, but there is an opportunity to use that solar to charge EVs directly next to the highway. Wireless charging lanes and direct current fast chargers allow for fast and convenient EV charging. And by using the energy close to where it's generated, we create a more efficient system that can improve the financial case for investment in both renewable energy and the EV charging infrastructure. So let's go into a little bit of a deeper dive on using the publicly owned land along our highways. So currently, each DOT spends millions of dollars annually to mow the right-of-way and to apply herbicides or pesticides to keep it maintained and safe. Our workforce is also put in harm's way every time they have to work along those roadsides next to speeding traffic. So we spend all of this money and we spend all of this labor to maintain turf that is really susceptible to erosion. We have erosion problems across the country, in all different kinds of soils, because we have a lot of water running off of our roadways, and the turf grass doesn't have very deep roots. So erosion is a big problem. So, what if there is a better way to do this? We think that renewable energy development in the transportation right-of-way can help the public agencies reduce their energy costs, reduce their land maintenance costs, increase resiliency and local energy security, restore degraded land through the use of native pollinator habitat under the solar PV panels, and create new revenue streams. So meeting those broader renewable energy and greenhouse gas emission reduction goals that are common, in many states throughout the US. So, it's a resilient and it's a reliable energy source because it is distributed and it is modular. So it's not as impacted by natural disasters or malicious attacks. For example, currently, a power plant, if a power plant were to go down, that means an entire city or an entire region could go down. If the grid goes down, that really impacts a wide swath of land and a lot of people. But by having distributed energy, one piece may go down, but we still have other, solar PV systems in place that can stay up. Using our roadsides for renewable energy relieves pressure to develop prime farmland or other ecologically sensitive areas to install solar panels. And solar jobs are labor intensive for installation, and the operation and maintenance is local by nature. So we support our rural economies that will be impacted by the transportation electrification future. The other thing too is we do have some federal incentives with the investment tax credit, and we can take advantage of the 5-year modified accelerated cost recovery system, which is a tax depreciated system for capitalized cost. And then many states have renewable portfolio standards and greenhouse gas emission reduction targets, like I mentioned, and they can monetize the renewable energy credits, or keep them and claim, the clean energy as, as reducing their actual emissions. Okay, so next we can use this renewable energy to charge EVs. So how do we accomplish this? We accomplish it through microgrids. So we can do this by connecting the solar panels directly to EV charging, DC to DC converter, or a DC to AC inverter, depending on how the system is set up. Using renewable energy generated locally is more efficient and more investable as a solar battery EV system than they are investable independently. So what that means is solar electrons for charging nearby EVs are more valuable than solar electrons put back onto the grid. It adds a level of resilience that we currently don't have. So we can provide fuel for our vehicles even if the grid goes down through these microgrids. In the very near future, we will be able to dynamically and wirelessly charge our vehicles through EV charging infrastructure built into the road itself. This technology is already here. It just is waiting to be deployed. We will also be able to use the renewable energy generated on the roadsides to generate clean hydrogen through electrolysis. So again, this technology is here. It is brand new, but it is ready to be deployed, and we just need to build it. So let's dive into existing solar in the right-of-way. So Oregon was the first mover in this area. They built 2 systems in 2008 and 2012, and they used private-public partnerships for both. Massachusetts DOT was the next, and they started in 2013, and they installed 4.3 megawatts across 8 sites through a power purchase agreement. Maryland DOT has a organization-wide solar program. So they are looking at all of their DOT assets to find places where they can install solar. They've already installed 1.8 megawatts on 5 sites, and they are looking and actively pursuing additional projects as we speak. And then Georgia, we have on the Ray a 1 megawatt pollinator friendly site. So we used 4 acres. It's a public project. We power the grid with this. It's grid connected. It provides roadway lighting as a part of this project, and it was commissioned in early 2020. So it was built in 2019, commissioned in 2020. And we are the first pollinator-friendly right-of-way solar. Okay, so here's what it looks like. It's on exit 14 on Interstate I-85 in West Georgia. And it's, like I said, 1 megawatt, so 2,600 high-efficiency solar panels. And you can see the safety setback from the travel lanes. And it's behind a crash barrier and also safety fencing. And then here is a picture of our beautiful pollinator habitat. And so, it's pretty simple to not just use turf for these solar PV sites. all of these sites, they have to have a vegetative management plan. So instead of using gravel or turf grass, like, we've done in the past, you can simply use a low growing pollinator-friendly seed mix around the panels. What's great about this is you mow it maybe once or twice a year. The roots are much longer, they go a lot deeper, and so we have less problems with erosion. And pollinator habitat can actually qualify for your MS4 water quality credits. All right. So last year, the Ray and Weber Energy Group at UT Austin, we partnered to estimate the potential for solar energy generation at interstate exits. So the results of the analysis are displayed on an interactive roadside solar mapping tool. And you can see the website up there, theray.org/technology/solar. And what we found through this analysis was that most states have about 200 miles of right-of-way at exits that is suitable for solar development. So interstate exits alone can support 22,483 megawatts in capacity. And that generates, like I mentioned earlier, 36 terawatt hours per year, resulting in a $4 billion economic benefit per year. And so again, that's enough to power 12 million passenger EVs annually. So what we're going to do next is take a closer look at this map. Okay. So when you go to the website, theray.org, you see under our new solar page this beautiful map. And you can see all of these, different numbers, which, is basically just a consolidation of the sites that are available for solar. So let's just click on Texas. We'll go to Austin because Austin is a super cool city. And you can keep clicking on the numbers to dive in. And you'll see, the little sun right here. And when you click on that, it gives you some of the basic information for this site. So it gives you the lat long, where it's located, the solar potential, 35 for this particular site, 3528 megawatt hours per year. And then the electricity value. So if you go up to the top right here, you can see the solar capacity factor, and you can change these different inputs depending on if you want to adjust the calculation. The state electricity rate, this will change pretty regularly, so you can see what the equivalent is. And then the area. So if you want to put in more precise area, or if you want to include additional land next to the interstate exit, you can adjust that as well. And you can see that when we do adjust it, it changes the numbers down here. So let's just take a look. When you click on the lat long, it then brings it up into a new Google map. And you can put this into, your existing enterprise GIS systems, or into a Google Earth doc to play around with more of the functionality, and just kind of get a better look at what's around, stores and things like that. But you can see that this is really a beautiful site for solar. I mean, it's clear of trees. It looks relatively flat. There's quite a bit of space there. Okay. So also, if you can see my cursor down in the lower left-hand side, you can download the map data. And let me go to that so you can take a look. Okay, so when you download the map data, it comes up with this spreadsheet. And it basically tells you all of the data that goes into it, and does the calculations for you. And it is, you can go to your state and search by state, by county, gives you the lat long, all of that good stuff. Okay, so I encourage you to go into the map and to play around with it. You know, if you go up to the top left, you can reset and go back to the main map. You know, and then just see what else is out there. So there's another site in Arizona. Okay. Okay, so to talk to some of the criteria when setting up solar PV in the right of way, for the UT Austin model that we used an Iowa data set, which provided a complete data set of their parcels. And we combined that with an analysis from the Bray Highways right-of-way solar. And so based off of those two data sets, we were able to estimate that about 41% of the space in the interstate exit area is usable when you consider safety setbacks. So the safety setbacks, obviously important for safe vehicle recovery distance and adequate site distance, has to be completely free from obstructions. Now, this can be increased. You know, you can use more than 41% if we have things like you know, guardrails in place. But generally speaking, it's, you know, a good rule of thumb. We also have other criteria that we need to consider when we site solar on the right of way. So, for example, you know, shade and obstructions. If there are trees or power poles in the way, other things that will obstruct the sun getting to the solar panels, you know, it won't be a good site. You know, there's competing use of property. Most DOTs have a highway needs inventory of some sort, and that is the projected 20, 25, 30 years of need for the highway. So you want to make sure that you take a look at those planning documents, because when you install solar in the right of way, the solar panels will last 20 to 30 to 35 years, and, you know, generate a lot of energy for a significant amount of time. So you want to make sure that you're not going to need that land for other projects like highway expansion, you know, transit, that kind of thing. The public sometimes uses the highway. So, you know, businesses may want to install signs. Sometimes citizens actually plant crops, which is interesting. And then some are concerned with view sheds. So it's really important to get the public involved and make sure that you can get them on board with the projects. At interstate exits, some of these things are not, you know, not as critical. So, for example, you know, businesses won't install signs at the interstate exits, but if you have, you know, some right-of-way land along the side of the road, you know, that may be where your neighbors might have a little more problem with installing solar. The total maximum daily load, so water quality treatment. There's a lot of areas in the U.S. where the DOTs actually use, you know, their rights of way to install, you know, water quality treatment best management practices. So, for example, you know, Maryland plants a lot of trees to comply with the Chesapeake Bay TMDL. And so, you know, those aren't going to be good sites for them because they can't cut the trees, and nor do they want to. They want to have that forest cover. But it's also important for them to meet the federally mandated water quality treatment requirements, you know, and that may be incompatible. The other things to consider are utilities. So utilities are often buried in the right of way. And so you just have to be aware of where they are and make sure that you can work around them. Signage. So there has to be a minimum area around signs that must be kept clear so that the traveling public can see them without hindrance. Operation and maintenance. So one, you have to have a clear path to get into the solar PV system so that it can be maintained safely. But also there are some areas in the DOT right-of-ways that are used for staging. For example, snow plows can be staged in some of these rights-of-way area that needs to be free. And then also interconnection. So I know I talked a lot about connecting this solar energy to EV charging. And I do believe that that's a great use of the energy, but you can also, interconnect it to the grid, which is how all of the current systems that are in place in the US right now are set up. And that's one thing that you would have to consider when building a project. So there has to be some kind of grid connection. A lot of times when you're only talking about 1 or 2 megawatts per site, if you have a good, distribution line close by, then you might be able to easily tap into it. But you don't know if the site is feasible until you get that interconnection analysis done and approved by the utility. And then I know we're talking a lot about, the roadside right-of-way, but for transportation agencies, there is also the option to, install solar panels on, buildings that you own, maintenance sheds, noise barriers, things like that, even canopies in parking lots, park and rides. And so, that's a little bit of a different type of project because you'll need, extra support, and you'll have to make sure that the structural integrity of the existing infrastructure can handle the extra weight of the solar panels. And so you just have to do that extra engineering on that side. Okay, so a little bit about how to set up the deal. So ownership. Right? So the agency can choose to either own the solar PV system themselves, or they can have a third party own the system. If the agency decides that they want to own the system, they can use the energy for local EV charging, or they can offset their energy load through virtual net metering if they decide to put it back on the grid, or they can sell it to the utility. And it really will depend on where you are in the US, where you're located, because each jurisdiction, each public utility has different rules. But they all have a process to onboard renewables that you would just have to work within. If the agency does not want to own the system, you can have a third-party utility or a solar developer own the system, and you can choose to either buy the energy generated through a power purchase agreement, where you agree to pay for the actual electrons that are generated at a set price. So, if you agree to buy the energy, then maybe your price would be 7, 8, 9, 10 cents per kilowatt hour. You can choose not to buy the energy and just collect a LAN or a capacity fee, or even set up a share of a percentage of the revenue that the developer receives. The agency can retain solar renewable energy credits regardless of if you own the system or if the developer owns the system. So some of the benefits, right? So why would a developer even want to do this? So the developer has the opportunity to receive all of the tax incentives that I talked about earlier, the investment tax credit and the 5-year modified accelerated cost recovery system. And then in the case of a power purchase agreement, they have a long-term agreement with a public agency that buys the power. And that is a stable customer. Even if the public agency doesn't buy the power, they're still generating energy that is sold onto the grid or through to the community through community solar agreements. for the public agency, there's actually a lot of great benefits. So when you work with the private company or a third-party developer or utility, there is zero upfront capital cost when the developer owns the system. They get to take advantage of full utilization of the federal tax incentives. As a public agency, public agencies are tax exempt, so they wouldn't be able to take advantage of the investment tax credit or the MACRS. And then if the public agency decides that they want to buy the energy, they get a favorable fixed electricity rate through a power purchase agreement. So we know that, utility energy prices fluctuate, and we really can only estimate, maybe once every 3 years where those prices are going. So it's kind of up in the air, but through a power purchase agreement, you know exactly what price you will pay for your clean energy for the life of the agreement, which is 20, 25, 30, 35 years. You can also generate revenue from the land or the capacity fee, or do some kind of profit share with the developer. So it's a revenue generating source. And then also, if the public agency decides that they want to, keep some of the solar renewable energy credits, they can include that in the deal, and they can either claim those credits and claim them as, running some of their operations off of clean renewable energy, or they can sell those renewable energy credits on the market and actually create another revenue source for the agency. Another great benefit is the public agency can transfer land maintenance costs from the DOT to the solar developer. So that piece of land, that is used for solar development, the DOT no longer has to mow it. They don't have to maintain it, because now the solar developer will take care of all of that. And then the developer is responsible for the performance and operation and maintenance of the system. So, if the system doesn't work, the DOT, if you're in a power purchase agreement, you don't pay for electrons that are not generated. And so it's in the best interest of the solar developer to actually make sure that the systems are, operating at peak performance so that they can get paid. So just, a couple of notes about, how else to get this done. So when we're talking about federally regulated interstate right-of-way, there's a lot of different right-of-way that DOT owns. Some is state, some is federally regulated, and then we have interstate. So for specific to interstate right-of-way, the feds allow 2 paths to actually complete these projects. And I know this is a little wonky, and if anybody has further questions about how to get this done, I'd be more than happy to help. FHWA does have some guidance on their website, but just very briefly, under 23 CFR 645, it allows the DOTs to complete projects, solar projects, under their utility accommodation plans, their existing utility accommodation plans, as long as the project meets the public test. So what does the public test mean? Basically, if the DOT is using the energy, or if it's going to the utility, or if it's going into a community solar program, that meets the public test. What would not meet the public test is if a private corporation, bought all of the energy for their use, or if they had a direct line to that solar energy, and it is not, given to the public. So that would not meet the public test. So if it doesn't meet the public test, the FHWA does allow you to use 23 CFR 710. And this is for when the state law either excludes renewable energy as a utility, which is, I think, fairly uncommon, but I think, it may be out there, or if the project is not serving the public. Okay. So just some wise words from our founder and president, from Harriet Anderson Langford. So she believes, and we believe at the Ray, that the interstate highway land is an under-leveraged asset. So we believe in our hearts that the right-of-way can be put to greater use, and it holds the key to modernizing our energy grid, accelerating renewable energy generation and transportation electrification. And not only can we generate clean energy for clean vehicles using transportation infrastructure that we already own, but state DOTs all over the country have the opportunity to tap into new funding sources through those land fees, resource share agreements, and other business models that the federal government endorses. So, Harriet, just like her father, Ray, is a visionary, and kind of sees things differently, which is fantastic. Okay, and then this is my information, and some of the partners we're working with. Okay, and I am all done.
Thanks so much, Laura. I think we have a couple minutes to do some questions for you. So one question we got, were there issues or concerns with installing solar panels in the roadway clear zone?
Yes, so it cannot be installed in the roadway clear zone. So we definitely need to leave that clear zone free. So safety is, of course, the utmost importance. And when we're talking about interstate roadside, generally, it's anywhere between 30 to 40 feet, depending on the location that we have to leave clear. And so after that 30 or 40 feet, that's where we can really start evaluating. And so I do understand, that some locations may not have that kind of space, but there are a lot of locations that do have, tons, acres and acres and acres of right-of-way along the roadsides past the clear zone.
Great, thanks, Laura. Another question from the audience, how have you dealt with fair market value and using the right-of-way?
Yes, so fair market value, you do have to use that under the 23 CFR 710. But if we get to install these projects under 23 CFR 645, under our utility accommodation plan, you don't actually need to use fair market value because it meets the public test. So if it meets that public test, you don't have to go through fair market value. But yes, the fair market value question is, it's tough. I mean, we like to call it 710 world over here at the Ray, and it is a tough world to enter. And part of that toughness is with fair market value because, this idea, one, is so new. That how do we value that land, for a long time, and we still continue. I mean, the idea of using our roadsides and our right-of-way under a stewardship model is, kind of a fairly new idea, right? So we've never really opened up our roadsides along our highways for additional beneficial uses. And so we don't, our real estate folks at the DOTs and at FHWA, I mean, it's hard to have, some kind of comparison for fair market value of the right-of-way. And of course, it will be different depending on, how close you are to population centers versus rural areas. We have examples of fair market value for land, with federal lands that we refer to, or even agricultural lands, but it's not exactly right. So I think that is one area that that definitely needs some work. And I know, a lot of great minds are working on that and trying to figure it out. But it's not, we don't have a great answer for that.
Thanks, Laura. What's the current state of disposal for solar panels?
Yep. So that's a big question, right? So there's a lot of companies out there trying to figure out how to repurpose and to recycle solar panels. I do know that there are actually a couple of states that are putting kind of a fee on solar panels that are sold within the state to account for recycling. So similar to like a tire or a battery recycling fee. So that they have those funds to make sure that they are recycled responsibly. And so, most of the time, I think the recyclers try to reclaim as much of that good material as they can for reuse, and then recycle the rest.
Great. If generated power is sold, is there any legal issues with commercializing highway right-of-way?
So if it is sold to the utility, it meets the public test, and it does not fall under commercialization.
Great. Have you looked into the PUC's adjacent lot rule? Does it apply to interstates that span an entire state?
So every PUC is different. They all have different rules, and that will be site by site, definitely. So the 1 megawatt solar farm on the Ray, that was built by Georgia Power. So they're the ones that own it, they operate it. The same thing with some other states. The utilities actually own and operate the PV systems. And so, all I can say is every state is different. So there's not a one size fits all for that question.
Great. What about glare from the solar panels? How do you ensure travelers are not impacted?
Yes, very important. So the FAA has glare rules for, anytime you develop solar or other infrastructure that could cause glare. And so normally it's within 3 to 5 miles of an airport, nautical miles. And so, there is not a specific requirement for highways to do a glare study, but what we recommend for all DOTs considering this is to use those same rules that FAA does. So anytime you have solar PV installed near the right-of-way or on the right-of-way near highways, use those same models that the FAA uses, and use their same procedures to make sure that you are not, you're not designing the PV system so that it kicks glare into drivers' eyes. But that's a very important safety aspect.
I think we have time for one last question. You spoke a bit about the benefits of working with a third party to develop the PV system. What are the benefits if the agency wanted to own and operate the PV system rather than allow a third party to own and operate it?
Yeah. So that's good. So if the agency wanted to own the system, the primary benefit really is economic. So if the agency can come up with enough capital to actually build the system themselves that they want to own and operate, then their payback is much faster. So they wouldn't be paying a long-term agreement with a solar developer for the life of the term, right? So if you enter into a power purchase agreement with a solar developer, you pay for the electrons for the 20 to 30 years, even though you know that rate. If you own the system yourself, you pay the cost of the energy, but then once the system is paid off, within 7, 9, 12 years, usually is the amount of time it takes to recoup your costs, you basically get free energy for the rest of the life of the system. So the economic ROI is better if you own the system. However, a public agency as a tax exempt, organization cannot take advantage of those, federal tax credits. And so those tax credits actually, reduce the capital costs of the system quite a bit. And so, what I recommend is if a public agency is interested in actually owning the system and realizing, that higher economic ROI, I actually recommend working with a third party solar developer in the beginning and doing kind of a hybrid system. So, what the agency can do is enter into an agreement with the solar developer or the utility, and the utility builds the project. They can take advantage of the tax credits. They get it up and running. They have a vested interest in making sure that it's up and running and it's, working as best as it can work with no issues. And then in the agreement, you can provide a buyout option. So, usually it takes about 5-6 years for the private entity to take advantage of the tax credits. And so they can own and operate it for that first 5-6 years. And then after year 6 or on year 6, the public agency can actually, decide to buy the system from the developer outright and take it over. But that way you kind of get the best of both worlds, I think.
Great. Thanks so much, Laura. I think that looks like all the time we have. Thanks everybody for joining us and allowing us to speak on the Ray and our projects with Solar Right of Way. Our team's already working on expanding the mapping tool to include more property data sets, more interactive functionality, and more layers such as transmission or distribution lines, floodplains, and endangered species. So stay tuned for what the Ray has coming, and we hope everyone has a great week. Thanks for joining us.
Thank you.